Now we have discussed lenses, a concave lens, a convex lens. Now we need to know how to use lenses. Now, one of the most important uses of lenses, one of the most important use is that they use them to correct eye defect, correction of eye defect. Now, the two eye defects that are important here are long-sightedness and short-sightedness. Long-sightedness is hypermetropia and short-sightedness is myopia. So those are the other names that they can call them. Now, for you to understand the concept of long-sightedness and short-sightedness, it's important for us to understand the concept of near point, and far point. Now, what do you call near point? Near point is the closest an object can get to you and you still see it very clearly. That's what you call the near point. Because when you bring objects close to you, they are going to be becoming bigger and bigger. They are going to be appearing bigger and bigger to you, and you get to a particular distance that you stop seeing the object very clearly. So at that distance, you have reached the near point. Now, the near point of an average person is supposed to be 25 centimeter. While what do you call far point? Now, far point is the maximum distance an object will be from you, so that you still be able to see it very. You still be able to see it. Don't let me say clearly. You still be able to see the object. Now, the far point of a person, let me represent it as f, is always infinity. It's always infinity. That means that when an object is very far away from you, you can still notice the object without ever stressing your eye. So when an object is at far point, it is very far away from you. That's why we are saying the distance is infinity, and you can still notice the object even though it might not be clear. But when an object is very close to you, it can't get closer than 25 centimeter, and once it gets closer than that particular point, you stop to see the object. Now, people that are long-sighted or short-sighted have a problem of either near point or far point. So that means that instead of their far point to be at the normal distance of infinity, the far point has reduced, and instead of the near point to be at normal distance of 25 centimeter, the near point has increased. So let's see how this is going to work. So let's assume that you have someone whose distance of distinct vision, instead of being at 25 centimeter, is now at maybe 70 centimeter. So what is happening to this person? So what is happening is that when this person wants to look at an object, don't forget the explanation we made for distance of least distinct vision. That means that when the object is getting close to you, you can still see it as long as the distance is greater than this distance. Until it gets to the distance, that's when your eye is very strained, and when it comes be within this distance, you can no longer see the object very clearly. So if someone's near point, let me write near point as n. If someone's near point is now at 70 centimeter instead of 25 centimeter, what is going on? It means that when you are bringing an object close to this person, and the object gets to a distance of maybe like 100 centimeter from the person will still see it. 90 centimeter from the person will still see it. But once it gets to 70 centimeter from the person will still see it clearly. But once it comes within 70 centimeter, the person can no longer see that object. So what are we going to say is happening to the person? You can see that when the object is very far from the person can still see it. But when the object is now within 70 centimeter, the person can no longer see it. And that's supposed to stop when the object is at where 25 centimeter, but that person's vision has already stopped before getting to where it is supposed to be. So what are we going to say? We are going to say that this person is what? Long-sighted. This person is not short-sighted. The person is long-sighted. So that means that someone that is long-sighted, we have their near point at a distance that is greater than 25 centimeter. Nearsighted people have their near points at what distance? A distance that is what? Greater than that of an average person, that of a normal eye, which is what? 25 centimeter. So in any question, once they give you a value for near point and you see that it's greater than 25 centimeter, and they told you the question that is the person's near point, automatically you should know that the person is long-sighted. The person is not short-sighted. Short-sighted people can see what is close to them, not what is far away from them. So what of far point? We know that the far point of a normal person is supposed to be at what? At infinity. Now far point is very easy to guess. You can't have distance greater than infinity. It's not possible. So that means that you have a distance, the person's far point is at a distance that is less than infinity. Maybe the person's far point is at maybe 10 meters. 10 meters. What does this mean? Now don't forget the definition of far point. Far point is what? The distance that you are going to move an object to. Don't forget that you are moving the object away from you. So the distance you are going to move an object to, such that you will still see the object, so that once you go beyond that distance, you can no longer see it. So for someone that has his own far point at 10 meters, what does it mean? It means that if you are taking an object away from the person will still see it. Once maybe 5 meters away, the person will still see it. Maybe 8 meters away, the person will still see it. 10 meters away, the person will still see it. Now once the object goes beyond 10 meters, the person can no longer see it, because far point, it has already exceeded that person's far point. So that means that if you have an object that is even at 11 meters, that is very close to 10 meters, the person will not see that object very clearly. The person will fail to see the object. So that means that for far points, since the person can no longer see the object beyond 10 meters, that means that the person cannot see the objects that are very far. So you can't say the person is long-sighted. Someone that is long-sighted can see things that are far. So you are going to say that the person is what? Short-sighted. So this kind of person is what? Short-sighted. While this person is what? Long-sighted. So a long-sighted person can only see what is far away. They can't see what is close. While a short-sighted person can only see what is close to them. They can't see what is far away. So it's now possible that they ask us questions that they are going to ask you to find what kind of lens you can use to correct this kind of defect, and probably the focal length. They ask you for the kind of lens and also the focal length and the power of that particular lens. Now another thing we should know, that we should actually know, is what usually causes long-sightedness and what causes short-sightedness. Now if a person is long-sighted, as far as I know, there are like two major causes of long-sightedness and short-sightedness. Is either it has to do with the person's eyeball and the lens of the person's eye. It has to do with what? The eyeball of the person and also the lens of the person. Now let's assume that we have the eye, then we have this. So we have an object at this particular point. Now let's say the image of this object is about to be formed, and the image is now formed at this point. You know what's supposed to happen is that this image is supposed to form on the retina. This is where the retina is. This image is supposed to form on the retina. Now this image is now formed in front of the retina. Now what do you think this person will have to do in order to see this image? The person will have to bring the image closer to the person, right? So that means that the person will have to bring the image closer. So what this means is that this person cannot see what is far, but can see what is close. That means that this person is short-sighted. short-sighted. And short-sightedness, if you look at the eyeball, you see that the eyeball is longer than where it's supposed to be. It's supposed to end here, but the eyeball extend beyond that point, so it can be caused by what? Long eyeball. So that's what one cause of short-sightedness. You should have guessed for long-sightedness. So that means that long-sightedness will be caused by what? Short eyeball. So they are like opposite. You see that short-sightedness is caused by what? Long eyeball. So long-sightedness will be caused by what? Short eyeball. So this person will have to move closer. So the person is what? Short-sighted. Now another thing that can cause short-sightedness, another thing that can cause it is what? The power of the lens of the person's eye. The power of the lens of the person's eye. So let's assume that we have light ray coming from an object at this point. So we now have the object at this particular point. So there is going to be lens, the lens of the person's eye at this point. So when light rays come like this, what are they supposed to do? They converge, right? Because this is a converging lens, so it's supposed to converge at the retina. But for people that are short-sighted, the light ray will converge in front of the retina instead of at the retina. So they converge at this point. You see that it still corresponds to what we are having here. The image is formed where? In front of the retina. So what is going on here? So what's going on here is that this person's lens is too powerful. The lens of the person's eye is what? Is too powerful. So they are too converging, to the extent that they even made the light rays to converge before they are supposed to converge. They are supposed to converge at this point, so they now let them converge in front of the retina. So short-sightedness can also be caused by what? Short-sightedness can also be caused by two converging lens. So that means that when the lens of the person's eye is too converging, so that is, the lens of the person's eye is very strong. So the opposite will be for long-sightedness. So that means that for people that are long-sighted, that means that the person's lens is very weak, so that they converge at a point that is beyond where they are supposed to converge. So that's like a way for us to know which one is which. Now let's now assume that we are now asked, what kind of lens can you use to correct this person is short-sighted, right? So what kind of lens can we use to correct short-sightedness? What will be your answer? Now what we need to do is that what? This person's eye lens is too powerful, right? It's too converging. So that means that we need a lens that will help us to diverge it, because you can't use converging again. The lens is already too converging. So if you still use converging, there will be problem. So that means that the light rays will continue to meet at point that is always in front of the retina. So you need a lens that will do what? That will first of all diverge these light rays. So you need a diverging lens, so that when the light rays pass through this lens, they will first of all go up, they will diverge before entering the lens. Then the lens will now converge them, and they will now meet at where they are supposed to meet. So that means that we need a diverging lens. A diverging lens to correct what? Short-sightedness. That means the opposite will be for long-sightedness. We are going to need a converging lens, because the lens is weak in that case. So we need a converging lens that will further help the eye lens to converge the image at where the light rays at where they are supposed to converge. So that is what? That's the theory behind lenses. Now they can ask us questions on this, like calculation questions. They just ask us to find what kind of lens you are going to use to correct this, and what's going to be the focal length of the lens. Now do not forget, okay, let me explain this concept. This concept is very important if you want to know how to solve those kinds of questions. Now let's assume that this is the eye, and we know that, okay, I don't think I need a diagram for this. So let's say a person's near point is at 50 centimeter when the near point is supposed to be at where? At 25 centimeter. We already know that the defect that this person is having is that what? The person is long-sighted. The person cannot see what is close. What is closer than 50? The person cannot see it. So this person is what? Long-sighted. And they can now ask you, what lens will you use to correct this person's defect? What kind of lens are you going to use to correct it? Now, do not forget, there is one important thing that you must note, that whatever lens that you are using to correct it, if you want to do the calculation, the lens will always form a virtual image, because you need the image to be in front of the person so that the person can see the image. You need the image to be in front of the person so that the person can see the image. So the image is always virtual. So that means that the image distance will always be what? Will always be negative. You need the image distance to always be negative, but the object distance will not be negative. The object distance is always going to be positive. Now let's try this question. How are we going to solve this person's problem? Now what we are going to do is that we know that the person can see as long as the object is not closer than 50 centimeter. Now we want the person to see when the object is closer than 50 centimeter. That means when it is at where? At 25 centimeter. So that means that when the object is at 25 centimeter, we still want the person to see that particular object. So what are we going to do? So that means that we need a lens that will take an object at 25 centimeter and take the image to the person's near point so that the person can see it. So that means that we need our lens to take the object, because where is the object? The object is at 25 centimeter. The object is what? At 25 centimeter, where the object is supposed to be, because the person cannot see object at 25 centimeter, so we need the person to see object at 25 centimeter. So we need a lens that will help us to take the object from here and form a virtual image of the object at that person's near point. So it's just like, you know that the near point of the person is at what? At 50 centimeter, right? So that means that before the person can see any object, the object must move away from the person till the object reaches this 50 centimeter. But we don't want the person to move away. We now want our lens to do the job for us, to help us to do the job of moving the image away. So that means that the lens will now look at the object at 25 centimeter, take the image of the object and go and put it at where? At 50 centimeter. So we are going to say that what's the object distance? What's the object distance? The object distance is what? 25 centimeter. I might have made a mistake here. So this should be positive, right? This should be positive and this should be negative, because this is for the object, right? You always have a positive object, but the image is the one that is virtual image. So then we need it to form image at 50 centimeter, but it's a virtual image, so you say minus 50 centimeter. So you now say 1 over f is what? 1 over v plus 1 over u. So this will be 1 over minus 50 plus 1 over 25. So what are we going to get? We get 1 over f is what? This is 50 minus 1 plus 2. So this is what? 1 over 50. So that means f is equal to 50 centimeter. So what does it tell us? This tells us that this is a positive lens. So you need what? You need a converging lens. You need what? A converging lens. Look at that. You need a converging lens because the person is what? Long-sighted. The person can see what is far. You see that it corresponds to what we have here. You need diverging lens for someone that is short-sighted. So you are going to need converging lens for someone that is what? Long-sighted. So this is what? A converging lens, because the focal length is positive. Now let's assume that we have another person that also has an eye defect. Now the person's far point is now at 20 meters. The person's far point is at 20 meters. Now ask us what kind of lens, and find the power of the lens that you need to correct this person's defect. So this previous one that we did, the only one we did was what? The focal length of the lens. Let's find the power. Power is what? 1 over f and power will be 1 over the focal length is 50 centimeter. Don't forget, always convert to meter to get the power. So 1 over 0.5, that's going to be 2 diopter, so plus 2. So this is what? A converging lens with a positive power. Now the person's far point is at 20 meters, right? Now the normal person's far point is at where? At infinity. So what will happen here? So that means that the person can see objects at 20 meters, but the person cannot see objects at infinity. So that means that we need the object to be at infinity, and the person will still see it at where? At his own far point. So that means that we need a lens that will go and take the object from infinity and bring it to the person's far point. So that means that it's going to form an image at the person's far point. Now this is like a common thing that we should know, that the image is always formed at either the person's near point or the far point. So that means that whatever you want to use for the person's near point or the far point must always be negative. Look at what we did here. This is the person's near point, right? When we wanted to use it, we use minus 50, because that's where the image is formed and the image is virtual. This is the person's far point, right? So this is where we want the image to be formed. So that means that we must use what? Minus 20 as our v. So v is going to be minus 20 and u is what? Infinity. Now what are we going to have? You know that 1 over f is 1 over v plus 1 over u. So 1 over f is going to be what? 1 over minus 20 plus 1 over infinity. Now infinity is too big to be divided by 1, so we get 1 over f to be 1 over minus 20. This will be 0. Now that means f is going to be minus 20 centimeter. This is a negative answer, so that means this is what? A diverging lens, not a converging lens. So that means that you need a diverging lens to correct the defect of someone that is what? Short-sighted. You need a diverging lens, which is exactly what you wrote here, that we are going to need a diverging lens. So we have minus 20 centimeter. Now what about the power? The power is going to be 1 over minus, this is 0.2, so that's going to be what? Minus 5 diopter. So that's going to be our answer. So please try to like jot things down somewhere, that someone can be long-sighted or short-sighted, the causes, what happens to the near point, what happens to the far point, what happens to the eyeball, what happens to the lens. So all those are very important, and know how to do the calculations for a near-sighted person and a far-sighted person.